Hello, this is the video demonstrating my road incident desk project. This project main objective is to provide user a clear information and insights using information visualization like graph, chart, or descriptive statistics, especially for people who are interested or required for road incident death data, and also for further analysis purpose to identify the cause, effect, or even patterns of road incident death, as well as the factor and relationship between data. Now, quick demonstration. This application contains three main pages. The first page is storytelling. The user can filter the years on the left side, which the histogram and statistic will be updated. On the right-hand side, user can select 8 of default graph I provide for them. And keep in mind that this year selection doesn't affect anything on the right-hand side. For data exploration, user can filter their interest parameters and generate them to get their wanted graph. I suggest you play with the filter bar a little bit. And the dataset page, which is contain the dataset used for calculation and graph generation. Now, after we see the user perspective, let's dive into the UML class diagram. In this, if you look at the whole diagram, you can see that it's divided into three main groups, which is MVC patterns. The left side is view, which is the UI. In the middle is controller, and the model is on the right, which is the generator, and the controller connect between them. And also in graph UI, you can see that it contains a lot of class and object and the widgets, which is the composite patterns. And the right hand side is the kind of factory that graph generator may call and get instead of whatever graph generator the user set, and kind of a state pattern in the filter bar. Now moving on to sequence diagram. Basically, user filter the data parameters in the UI, which is the data exploration, and then it called the controller generator, which is the attribute in the controller, and then set up it and update the UI if needed. After the user is satisfied and press generate for the graph, it set up the generator for the last time, and then the controller handle generate and get the generator from the graph generator, which create the whatever generator the user wants, and that specific generator will create a graph and return a graph and destroy itself after it, and controller return a graph to the UI. The UI update the graph and display the new graph to the user. Okay, now for GUI design, coming back, the application is created using TK inter in Python, so I will mention them as if I use wildcard import. The main window is TK, and the main widget I used is ttk.notebook, which stores the three main pages, which are all ttk.frame, and all of the graph and charts in this application is ttk canvas. In detail, is the first page contains a combo box on the upper left, the label, and this buttons is keypad. I name it keypad, which is a frame contain a lot of buttons, TTK frame. And the second page, we have canvas and the filter bar, which is the frame itself and contain a lot of TTK combo box and label, and the select type filter contain is a TTK frame contain a lot of buttons. and generate is a, a button, of course. And the dataset page is trivial with the scroll bar. Now for data processing parts, or dataset that I use from our work in data and World Health Organization, as known as WHO. I put the link in the README file already, so feel free to check it out. In the storytelling page, the attribute I used is death rate in basically every graph and chart, and the type of death, including different ages and different vehicle, the rural and maximum speed limit by country, which used in these 5 graphs, and the existence of civil law in each country, which is by this graph. And few things I find interesting, which I discovered from the data storytelling page, is first, the seatbelt existence makes the average death rate lower. Furthermore, and the relationship of speed limit and death rate tend to be small positive for both rural and urban. But you can see at the bottom of the graph that urban has stronger relationship a little bit. On the other hand, when I divide the speed limit to the many range, urban look like they have no relation, but for rural they have really clear positive relation. This can happen, in my opinion, maybe many factors. Maybe because the population in rural is larger than urban. But for now, we can conclude that the maximum speed limit has some positive influence on the road incident death rate. And some for the extra feature, actually the dataset page is not needed in the requirement, and all of the filterable feature combined is also a little bit more than the requirement. So like the mode feature, the graph feature, which I really recommend you to play with it. And that is it for the video. Thank you for watching and see you later.